This is exercise number 24 for the exam FM on financial mathematics, offered by the Society of Actuaries, also exam 2 of the Casualty Actuarial Society. You have some information here about me and where this exercise is posted online, where you can get my study manual for exam FM, where you can find the online seminars for exam FM offered by Illinois State University, and most importantly, where you can offer support for scholarships for our students at Illinois State University. Please consider any amount would help. Our students badly need scholarships. Please remember that. So here's the story. You are the investment actuary of the exciting life insurance company. Your company must make payments of $1 million in 1 year and $2 million in 2 years. There are 2 bonds available to invest in. One is a $1 million 1-year risk-free zero-coupon bond with yield to maturity of 4%. And the other bond is a $1 million par, so that par amount of that bond is $1 million, 2-year risk-free annual coupon. So the bond will pay an annual coupon, the coupon of 5%. So it'll pay 5% of $1 million at the end of the first year and at the end of the second year, and then it will pay the par amount of $1 million at the end of 2 years. This bond is currently trading at the yield to maturity of 4.4%. Calculate the yield to maturity on your company's liabilities portfolio. Now notice that this is a yield on the liabilities. You are given the information about the individual assets and the yield on them, but the question is about liabilities. So why do we have all this information about the assets, the bonds? Because they give us information about interest rates in the market. Note that to the customer of this insurance company, these payments of $1 million in 1 year and $2 million in 2 years, assuming that it's one customer, but it doesn't really matter because whatever it is to this insurance company, it's their liability. And what I'm trying to say is to a customer of the company, this is an asset. That asset is not traded in the market, but we are saying that if it were traded in the market, it would have a yield to maturity, and we are supposed to figure it out. And the main message of this problem is there are assets in the market that can be used to replicate, to copy exactly the liabilities portfolio of this insurance company. And now remember the strawberry principle, that if 2 financial assets make exactly the same payments, they must have the same price, they must have the same yield, they are the same thing. So what we need to figure out is, based on this market information that we have about the interest rates, if you have a portfolio that pays $1 million in 1 year and $2 million in 2 years, what is its yield to maturity? This problem may be somewhat confusing, but it's intended to make you think about the meaning of what the yield to maturity is. Yield to maturity is one interest rate used for all maturities of the bond or whatever asset that we're considering, the same interest rate used for each payment that, when used to discount those payments, will give you the price today. Now, we have other bonds here, and one of them has a yield, but it's a zero-coupon bond. For a zero-coupon bond, the yield is the same as the spot rate for the time to maturity, and the other bond has a yield. But those 2 bonds will give us the information about interest rates in the market. And the crucial information that they will give us is they will tell us what the spot rates are for 1 and 2 years. From that, we will know what the price of these liabilities, of these payments of $1 million and $2 million, is in the market if you combine them. because we will have the spot rate for 1 year and the spot rate for 2 years. And once we have that, we will be able to figure out one interest rate used for discounting for both payments that will result in the same price. And that one interest rate used for discounting of every cash flow is called the yield on the portfolio. Okay, so let's take a look at this. We know that $1 million 1-year risk-free zero coupon bond has a yield to maturity of 4%, but this is a single payment. And for a single payment, the yield to maturity of the spot rate is the same thing, because the spot rate is defined as the yield to maturity of a zero coupon bond for the corresponding maturity. So 1 year spot rate in the market is 4%. Now, if S2 is the 2-year spot rate, then based on the pricing of the 2-year bond, we must have, take a look at what this says. The 2-year bond pays $50,000 in 1 year, and $1,050,000, which consists of the $50,000 coupon plus $1 million par payment. The maturity payment is the par value of the bond, and that's paid in 2 years. And the left-hand side of the equation here has them discounted at the yield of that bond, the same interest rate used for discounting of every cash flow. That's called a yield. And the right-hand side has the individual payments discounted at the corresponding spot rates. So the payment in 1 year is discounted at the 1-year spot rate, and the payment in 2 years is discounted at the 2-year spot rate. Now, 1 plus S2 is squared at the bottom because we're discounting over 2 years. The spot rate is the rate for 2 years, but it's an annual rate, so we discount over 2 years. Well, as you see, there's only one unknown in this. It's S2. So it's actually a reasonably simple equation. We solve it for the spot rate S2 after a little bit of algebra, and we get about 4.41% as the 2-year spot rate. Now we write Y for the yield to maturity for the liabilities portfolio that we are looking for. And the liabilities portfolio consists of $1 million in 1 year and $2 million in 2 years. On the left-hand side, we discount them at the corresponding spot rates, and once we do that, we will get the price of that portfolio from the market interest rates. So it's a market price, even though it's not traded in the market, but you can replicate that portfolio with securities from the market, so it has the market price. And the right-hand side has the same cash flows discounted at the yield. Now, this is the key thing for you to remember. The definition of yield is that it's one interest rate used for each cash flow, such that if you use that interest rate for discounting of everything, you get the current price. And we get the current price on the left-hand side from the spot rates in the market that we get from the assets traded in the market. So we calculate the value of the left-hand side, and it's 2,796,157.73 approximately. Now, to simplify things a bit in solution, we write a new variable z equals 1 over 1 plus y, and after dividing everything by 1,000,000, we get this quadratic equation, 2z squared plus z minus 2.796157773. I'm using as many digits as I can to be as precise as I can. Equals 0. We use the quadratic formula to solve that. We get two solutions. One is negative, so it doesn't make sense, and the other one is positive. And only the positive solution makes sense, so that's the solution. Now, since z is equal to 1 over 1 plus y, we can see that if we take 1 over z and subtract 1, that will be y. So we do this calculation, we get it to be 4.32488809%. That's answer C, and that's a complete solution. And I hope that you have learned the relationship between the spot rates and the yield in this. That's the crucial message of this problem. Thank you very much for watching this video and for being interested in this exercise. It's copyrighted by me. Please do not use it as yours. It's available for everyone, but please attribute it to me. And please remember that if you're grateful, support scholarships for our students because we need the money very badly. And good luck in your studies.